Dear friends, hold on to your telescopes because we've found an exoplanet hotter than a supernova. And it is Trappist-1e, a potentially habitable planet strutting its stuff around a red dwarf host star. But here's the cosmic twist: its atmosphere is playing a disappearing act. Electric currents are the cosmic choreographers here. As our planet pirouettes around its fiery partner, these invisible currents tango with its delicate atmosphere. Trappist-1e isn't just any old space pebble, it's part of the Trappist-1 system, a star-studded neighborhood where scientists have been stargazing for signs of alien life. Imagine the cosmic paparazzi, 7 Earth-like planets, 3 in the Goldilocks zone. That's the sweet spot where liquid water might flow, and life could throw a celestial soiree. Now there is a strange thing: Trappist-1e is losing its atmosphere faster than a comet streaking across the Milky Way. Without that cosmic raincoat, liquid water slips away like stardust through cosmic fingers. But wait, there's more. This cosmic caper might be a system-wide affair. Are the other planets in the habitable zone? If we talk about Trappist-1, its mass is 0.7 times our Earth and its 1 day is 6.1 Earth day. The Trappist-1 is facing more solar wind as compared to Earth. Therefore, Trappist-1e moves quickly around its star, and the motion drives powerful ionospheric currents that dissipate and create extreme heating, which the team calls voltage-driven Joule heating. Because of this strong reaction, it may be assumed that the atmosphere of this exoplanet will vanish. This is due to strong radiation from the star, which can cause the atmosphere to heat up and escape, or charge particles in the stellar wind pelting planets, causing a strong stripping effect. In this case, the heating of the atmosphere, and its loss as a result, are driven only by the rapid planetary motion. So, the planet dooms itself to lose its atmosphere by simply moving around. Dear friends on Earth, our magnetosphere protects our atmosphere by diverting charged particles down magnetic field lines and out behind our planet. Mars, lacking a strong magnetic field, has had its atmosphere stripped by solar winds and harsh solar radiation. The red planet probably lost its water to space as a result. Trappist-1e is also believed to have a magnetosphere, but these findings show it might not be sufficient to prevent atmospheric stripping. Normally, a planet's magnetic field acts as a protective bubble, but around Trappist-1e, this bubble is compromised. The planet's magnetic field connects with the stars, creating pathways that allow the star's particles to hit the planet directly. This not only vanishes away the atmosphere but also heats it significantly, leaving Trappist-1e and its neighbors vulnerable to losing their atmospheres entirely. Trappist-1e is the 4th planet from the red dwarf star at the heart of this fascinating planetary system of rocky worlds. Astronomers have previously discovered that Trappist-1b, the closest exoplanet to the star, seems to have already lost its atmosphere. The team thinks voltage-driven Joule heating could also be impacting Trappist-1f and Trappist-1g, stripping them of their atmospheres as well, albeit to a lesser extent than they see happening with Trappist-1e. That's because at 0.038 and 0.04683 times the distance between Earth and the Sun from their star respectively, these planets are moving slower through the red dwarf's stellar winds than Trappist-1e is. The scientists' findings could have implications outside the Trappist-1 system, as well as in the search for habitable exoplanets and life outside the solar system. They suggest exoplanets close to their stars have likely lost their atmospheres even if they are well within the habitable zone of that star. The discussion suggests that such low-mass host stars are probably not the most promising for hosting planets with atmospheres. Identifying which host stars can be conducive to habitable planets and observing those atmospheric transits with James Webb Space Telescope and future observatories. Thanks for watching the video.